Okay. In 17 and in question 24, we're going to look at both of those here. These are work problems. These are called work problems. And in work problems, what we're going to do is we're going to try to find out if I can do the job in so much time and you can do the job in so much time, how much time would it take us to work together? Okay, so these are actually work together problems. Okay, so in 17, it says Matt can plow out all the driveways on a street with his four-wheel drive truck in 6 hours. His neighbor can use his new snow blade with his lawn tractor and do it in 9 hours. How long would it take them to work together? So in this problem, I would suggest writing out some information. We know we have information about Matt and his neighbor, and we know how long it takes them to do the whole job. Okay, and then we're going to be looking for their together time. So the time it takes Matt to do the whole job, we said from the original problem, was 6 hours. So this is the whole job in hours. So it takes him 6 hours. His neighbor did it in 9 hours. And how long does it take them to do it together? That's what we're going to look for in this problem. Okay. Now, it wouldn't make sense to add their times together. It shouldn't take them 15 hours if they work together. If we averaged it out, the average would be between 6 and 9, and it shouldn't take longer than what Matt could do by himself. And it wouldn't make sense to just subtract these two times either. So can't really do anything with these numbers, but what you can do is you can compare their rates. And we're going to look at their rate per, in this case, hour. So we're going to figure out what their rate per hours are. Well, if it takes Matt 6 hours to do the entire job, then each hour Matt should be able to do 1/6. 1/6 the first hour, 1/6 the second hour, 1/6, 1/6, 1/6, 1/6. Then if you had 6/1/6, that would be 6/6, which would be one whole job, because 6 over 6 gets you 1, and that's the whole job. So if Matt can do it each hour 1/6 of the job, his neighbor should be able to do 1/9 of the job per hour. That would be his neighbor's rate. Their together rate would be 1 over x. Now, although we couldn't add their times together, we can add their rates together. So in this case, we have 1/6 for Matt plus 1/9 for his neighbor, and that would equal their together rate of 1 over x. So now we just have a basic proportion here, which we just need to come up with a common denominator. So for 6 and 9, we have a common denominator of, looks like 18. And we also need an x, so we're going to multiply through each of these terms by 18x. So it might not hurt to write this multiple times. So here, first term, cancel the 6 with the 18x, which leaves you with 3x. Cancel the 9 with the 18x, which leaves you with 2x. And then here the x's cancel, which just leaves you with an 18. Add this together, you get 5x equaling 18, or x equals 5 into 18 goes 3.6 times, or that's 3.6 hours. Okay, which is the total amount of time it takes them to do the job together.